5H, allow me to record a few more discussion with you about the prelim paper 2021. Remember, this was where I ended 2021 prelim paper. We were saying that after this cup is filled, the CG is higher. CG is higher. So it's less stable. This was where we ended. And then if you go down further and take a look, the question said that the filled cup is given a push with a force of 2 Newton, figure 4.2. So this one, taking the point P as a pivot point, explain with the calculation whether the cup will topple. Okay, so if you recall moment, this one has got something to do with moment. Whenever it talks about stability, topple, this calculation has got to do with moment. Okay, so recall moment, the calculation is force times distance, the formula. Okay, so if you look at this diagram, if this cup is pushed by the 2.0 Newton, it will turn clockwise direction. We have to check whether the clockwise moment is greater or lesser than the anti-clockwise moment caused by this pulling by the weight. This is the anti-clockwise moment. Okay, so one give you the clockwise, one give you the anti-clockwise. So let's look at clockwise first. So the clockwise has a force that goes this way, 2 Newton, and the perpendicular distance is the 10 cm perpendicular distance to the pivot point. Okay, so let's calculate the clockwise moment. Let me put the clockwise moment here. Clockwise moment equal force times distance equal 2 Newton times the distance is perpendicular distance is 10 cm. So that gives you 20 Newton cm. Let's calculate the anti-clockwise moment now. If I look at the anti-clockwise moment, let me erase this. Anti-clockwise moment is caused by this 5 Newton force. Because if the cup is tilted, this 5 Newton will pull it back anti-clockwise. So this is the anti-clockwise moment. So this force, which is we have calculated, it has shown the weight is 5 Newton. The weight is 5 Newton. So this 5 Newton times perpendicular distance, which is this amount. Okay, perpendicular distance is the 2.5 cm. Because the center CG, weight from the CG is at the center, it always cut the line into half. The bottom distance into half. So 2.5 cm. So this anti-clockwise moment is equal to force times perpendicular distance. It will be 5 Newton times 2.5 cm, and that gives you 12.5 Newton cm. So we can see from here that the clockwise moment is greater. So in your answer, you will see that since clockwise moment is greater than the anti-clockwise moment, that means the cup will topple. Okay, the cup will topple. So that's what we mean by calculation. Stability always has got to do with moment, stability. I draw an additional diagram here to help explain. If there are two, if this box is tilted, let's say tilted to some degree, tilted, let's say to some degree from the floor, from the ground, okay? And if I give you two CG, CGA and CGB, let's explain its stability if the CG is at A and the stability if the CG is at B, okay? So when you explain whether an object will topple or whether it will not topple, you always answer with moment, So let's take a look, okay, at the CG. Let's say if the CG at A, will the box topple? Will the box topple? So let's draw the vertical line of action of the weight. If CG is at A, the weight will be acting here, this way down. We can see that if the CG is at A, the weight will be on the right side of the pivot here, the pivot point here. Okay, it will be at the right side of the pivot. There is a distance to the right. There's a distance, perpendicular distance to the right. So this will cause a clockwise moment. If the weight is acting on the right side of the pivot point, it will cause a clockwise moment and the box will topple. So how do we answer in this case? If CG is at A, the weight acts on the right side, of the pivot. This causes a clockwise moment. The box topple. Hence the box topple. Okay. On the other hand, if I look at CG at B, if the CG is at B, then if I draw the weight, the line of action of the weight, it will be on the left side of the pivot point. If it's on the left side of the pivot point, it will cause an anti-clockwise moment. So the weight, same thing, the weight acts on the left side of the pivot, causing an anti-clockwise moment. Hence, the box will not topple. So let's look at the answer. Let's look at our answer again. If I look at my answer, I must always see how I draw the weight. I must describe the weight acting on which side of the pivot. Then whether it will cause a clockwise or anti-clockwise moment, then you conclude whether the box will topple or will not topple. Okay, so whenever you try to describe stability, whether an object will topple or not, you must bring in how the weight is acting and whether there is a clockwise or anti-clockwise moment. Okay, stability always go with moment. Okay, next question. Question 5. It says that question 5 says that the arrow has a mass 0.075 kg and there's an average force pulling the string down a distance of 20 cm. That means originally the string is at this line. Okay, it's at this line, but it was pulled down 20 cm. Hope you can see. Let me enlarge. Okay, it was pulled down 20 cm. So there is a stored elastic potential energy. Elastic potential energy. Ready to release the arrow. Now, if I were to describe the main energy conversion taking place, we will therefore describe. When you say describe, you must mention the energy comes from where. Okay, so conversion is the elastic potential energy of the pull string. So upon release, it will be converted to what? The arrow flies off. So that is converted to kinetic energy of the arrow. And as the arrow flies further and higher up, it gains gravitational potential energy. So from Ke2, gravitational potential energy of the arrow, Okay, so this is how the energy conversion will be. To calculate the amount of energy stored in the arrow before it's released, we all know that it comes from the elastic potential energy. But we only learn three formula to calculate energy. Okay, there are only three formula. There's work equal force times distance. Number one. Number two, Ke equals to half mv squared. And number three, potential energy equals to mgh. So in this case here, which formula would you be looking for? If you look at the hint given in the question, is you see mass, you see force, and you see a distance 20 cm. Okay, mass, force, and distance. Which formula with this information, which formula allow you to find the stored energy? Okay, which formula? You have force and distance, so you should be looking at work equal force times distance. Okay, so with work equal force times distance, you can go for 80 Newton multiplied by 20 cm. But be very careful, the 20 cm is a non-SI unit. In order to get joules for work done, you must have force in Newton and the distance in meter. That's SI unit. So 80 Newton times 0.2 meter. There you will get 16 joules. Okay. Then sometimes question will ask, with this amount of energy now, what kind of maximum height will you reach? The maximum height. So there's only one formula with height that you can use in this chapter. Okay, potential energy. So now you see potential energy equals to mgh, and the h is the one that you want to find. Okay, so from here you can tell that the potential energy, this work done in stored in the arrow, will also be converted to maximum potential energy. So the 16 joule is equals to mass 0.075 kg. It's already in SI unit. Let's take a look to confirm. Yeah, it's already in kilograms. So that's the SI unit. And multiplied by the G is always 10 and the H. So therefore, your H is equal to 16 over 0.75. Okay, after you take 10 times 0.075, you get 0.75. Oops, sorry. Back to the question. Okay, so that will give you the answers that's needed in meter. Okay, answer is in meter. Why the maximum height reached by the arrow is usually lower? Whenever question asks you why in actual reality, why it is always lower than the calculated value, the answer always has got to do with energy loss. There's thermal energy, okay? Thermal energy loss to the surrounding, loss to the surrounding, loss to the surrounding due to due to due to air resistance. Sometimes it's about box sliding on the floor or on the up the slope. It will be a thermal energy loss to the surrounding due to friction. Okay. All right. One last question. If you turn to the question 11 that we mentioned about melting and boiling, that kind of question. Let's look at the graph. That's question 12D. Question 12. Okay. If we look at question 12, this question was badly done in last year prelim because students also did not get the hint from the question. The question actually started with what? Hot molten wax. Hot molten wax is what state? It's a liquid state. Hot molten wax is a liquid state. Okay. So it is hot liquid state that will guide you in the graph. Will guide you in the graph. This is important because the starting information tells you whether the initial part of the graph is a liquid or is a solid. So it's a cooling curve. This molten wax, remember this molten wax, huh? Molten wax is started as a liquid form. So it's left to cool, it's a cooling curve. So we didn't start with gas, we started with liquid. Okay, so for it to cool, and when you see this happen, this something must have happened for it to change down to this part solid. From liquid to solid, down here is freezing or solidification. It's freezing and the temperature stay constant. So whenever you answer this kind of question, you must be able to determine all the states first. The states, state it clearly right on the side of the graph. State clearly what state is it in, okay, what state is it in, and what process is happening. What process? Okay, it's freezing. When you state that, then you are ready to answer the question. Like let's try part one. As the liquid wax cools down, the volume of the wax decreases. So in kinetic particle theory, that talks about molecules, structure of the solid, liquid, and gas. Explain why the volume decreases. So we know that when something cools down, okay, when something cools down, it will contract, right? It will contract, and when it contracts, the volume decreases, right? So using kinetic theory means explain in terms of molecular structure why the volume decreases. So molecular structure, we take a look when something cool down from high temperature to a lower temperature. Okay, high to low temperature. Let's say 80 degrees Celsius to let's say 50 degrees Celsius. Example, cooling down. What will happen to the movement of the molecules and what happened to the molecular structure in terms of spacing, because volume has got to do with spacing. What will happen to the spacing between the molecules when it contract? The spacing or the distance between the molecules become shorter. Okay, it becomes shorter. So the molecules become more closely packed. Okay, so in your answer you have to state that the spacing between molecules, be it solid or liquid state, when something is cooled down, the spacing between the molecules decreases. Or another word, more closely packed. They are now more closely packed, and because of that, therefore the volume decreases. Okay, volume decreases. Now, two big mistakes that students like to say. Okay, students sometimes will say because the size of the molecule decreases. Size of the molecules never decrease. It always stays the same. What decreases is the distance between the molecule. Then some student will say another mistake the student made was they said when the liquid changed to solid. The question didn't say the liquid changed to solid. You read the question carefully. It says as the liquid wax cool down. Cool down. It didn't say when it freezes. If the question say freezes, then you say from liquid to solid. But this one is only talking about temperature cools down. The temperature of the liquid wax decreases. So it's still in liquid state. It didn't become solid. So even in the liquid state, when the temperature drops, the spacing between the molecules decreases. That's all that you need for the 1 mark. Okay, 1 mark. Now next, state the section. Section means you always have to state from what to what. Okay, section of the graph. Okay, where you see both liquid and solid. So we all know it's at the freezing state. Freezing state where you see both liquid and solid. So this is the part where you have to say state B to C. B to C. Never just state one point because we are talking about section. If you say only point B or point C, you won't get the 1 mark. You have to say from what to what. Section means B to C. Okay? State the difference in the movement. This one again tests you on the kinetic theory. Movement of molecules. Just say the movement in section AB and section CD. So it's very important. AB is what state? AB is in liquid state. AB is in liquid state and CD is in solid state. So it's actually asking you in AB what is the movement like and in CD what is the movement like. So in short, I divide into two portions. So AB is a liquid state. Okay, liquid state. So the movement of molecule from A to B, the molecules glide across each other in cluster. Okay, and in CD is a solid state. Solid state. So how do the movement? How is the different is the movement? The molecules vibrate. Okay, vibrate in fixed position. In fixed position. So that's the difference you have to state for the 1 mark. Because in AB it is in liquid state and in CD it is in solid state. Okay, solid here is in liquid. So you are tested in all this thing. Okay, about kinetic theory. Describe what happened. Next question. Describe what happens to the intermolecular force. Did the force become stronger or did the force become weaker? Okay, of the wax molecule as it changes from B to C. Changes from B to C. So read the question carefully. It only tell you about B to C. Let's look at the graph B to C. B to C. From B to C. B to C is going from liquid all the way to become solid completely. So in this change from liquid to solid, how is the force? How did the intermolecular force change? Okay, so for it to become solid here in solid, it become very closely packed. So did the intermolecular force increase, become stronger, or did it become weaker? So to become more closely packed, it must have become stronger. So that's all you have to say, lor. When when we describe what happened, we must use the right term. Did it become stronger or weaker when we talk about when we want to describe the force? Okay, so you have to say the force, the intermolecular force becomes stronger. Okay, that's all they ask for. All right, for the 1 mark. Just try one more of such question in the 2019 prelim. Allow me to share this with you. In 2019 prelim, I see this question 10B. This is 2019. Okay, 2019 prelim. okay, I see this 10B about, again, is about a cooling curve, a cooling graph. Cooling because the temperature dropped, okay? So it's about a black can being filled with hot liquid at an initial 95 degrees Celsius. So if you read all this important information and do your trunking, trunking, that means highlight what is important, you 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 are able to see that this section start with what state. Then you will be able to conclude the last section ends with what state. So we must write all these things very clearly first. From P to Q, it says it started filled with a hot liquid. So it's liquid first, very hot liquid. Then uh, it's cool down, shows the temperature time graph for the black can over a period of time. So cool down, for it to become RS, at RS it must have become solid also, which means P to Q is a period of freezing. Again, it's a freezing period. But the questions are all asked differently this time. State whether the thermal energy is absorbed or released. Absorbed or released. When something cool down and is freezing, the it started with high temperature and the temperature dropped. So it must have involved thermal energy being released and not gained. If it's gained or absorbed by the body, then the body temperature would rise. But now we see temperature drop, so it must be released. Okay, so release. Okay, release. So first part done. The second part, describe and explain the changes, if any, to the potential and kinetic energy. Potential, kinetic, whether there's any changes. So when you say any changes, you cannot say yes, there's changes. You have to say whether it increases or it decreases. Okay, so down here, potential energy has got to do with the spacing, the distance between the molecules. Kinetic energy has got to do with temperature. Must always remember that, temperature. Okay, so from, we are only talking about from Q to R, this segment Q to R. So from Q to R, what do we see here? The temperature remain constant. The temperature remain at 54. So what does it mean for kinetic energy? If temperature don't change, then kinetic energy stays the same. It doesn't change also. So kinetic energy remains constant. Remains constant. Okay? But what happened to the potential energy from Q to R? We are changing from, again, let's take a look, what state to what state. We are changing from Q, liquid state, all the way to R is a solid state. What happened to the spacing between them? The spacing become nearer. They become more closely packed. The closer they are, the lower the potential energy. The further things are apart from each other, the greater the potential energy. Just like if you leave your bag higher from the floor, the further you are lifting the bags from the floor, the further the distance from the floor, or the higher it is from the ground, the greater is the potential energy, gravitational potential energy. So since from liquid to solid, the spacing decreases. Spacing decreases because in solid state molecules are even more closely packed. What does it mean? It means the potential energy decreases. Okay, the further apart, the greater the potential energy. Okay, so part 2 done. Part 3, the experiment is repeated with polished can. This one has got to do with radiation. Whenever mentioned polish or black can, it has got to do with radiation. The temperature time graph of the polished can is then drawn. Describe the difference, if any, you would expect to observe in the section PQ, QR, RS between the two graphs. Okay, between the two graphs. So state, okay, so let's look at the graph. If it is a polished can, will it release thermal energy faster or slower? We have to ask ourselves. Will it be faster or will it be slower? So if we all know that black color can emits heat faster at a faster rate. That means it cool down faster. but for a polished can, it emits heat slower. Okay, so since it emits heat slower, then the graph will look like this. For polished can, if you look at my drawing, because temperature drops slower, it emits heat at a slower rate, but uh, and it takes longer time to freeze. Since it takes longer time to release energy, it will take longer time to freeze. The Q and R will be longer, and then from R to S again, the slope will be more gentle, gradient will be more gentle. Okay, more gentle. Okay, so how do we describe that in our in our in English? All right, for PQ, the gradient will be the slope or the slope. Okay, the gradient or the slope will decrease. Gradient is more gentle, the slope is more gentle. Is more gentle. Okay, slope is more gentle, or the gradient decreases. Another word, or gradient decreases. Okay, when your slope is more gentle, the gradient is always smaller. Let's talk about QR. What did we say about QR? The line will be longer. QR is longer. It didn't ask for explanation. We just have to state the difference. How about RS now? RS, the gradient again, the slope is more gentle. More gentle. Okay. Finally, state two common properties between infrared radiation and sunlight. So all this you must have already memorized. The electromagnetic spectrum, the wave. What you learn three common properties. So state any two of them. That one you can go and refer to the answer. Okay, refer to the answer on your notes. You have learned them. You remember there are three. First of all, they are all transverse wave. Number two, they all travel at the same speed, right? The same speed of 3 times 10 to the power of 8 meter per second. Must take the unit. A lot of students want to say about same speed. I better say something here because a lot of students say same speed of 3 times 10 to the power of 8, and then they leave it there. There was no unit mentioned. You must mention the unit times 10 to the power of 8 meter per second in what? In air or vacuum. Okay, in air or vacuum. Of course, the third common property is that they can all travel in vacuum. Okay, but if you want to state the speed, please mention 3 times 10 to the power of 8 meter per second in air or vacuum. Must state the medium. Alright, because in other medium like glass or water, they will travel at different speed already. Okay, that's all I want to share with you. These are the few important questions I want to share with you in class, because these are what we have seen last time, how students have mostly answered wrongly. All right, that's all. Thank you.